Starting. Okay, good morning, everybody. How are you doing? Did we get them all yet? One, two, three. Three, that's it? Only have three? All right, well, we'll start with three. Okay. Good morning, welcome to Review Week. This is it. This is your final chance to prepare for the oncoming. Okay, it's not a big deal. Like usually, yeah, end of the semester, the exam. It's a great big thing. It's not as massive this time around. Okay, take the quarter test. All right, and we're gonna mimic that, except you get what is it, like 75, like more than double the amount of time on it. Okay, plenty of time. Still gonna be 20 questions, or thereabouts, maybe 22 tops, right? A couple of notes before we begin with the review today. So your specific exam time is in the master schedule for the class. So if you're wondering, hey, when is this class's one? You can find it right there. I believe for you guys, then you are on Wednesday, if I'm not mistaken. So that is when you will have the review. Everything else is due before that. I want everything else done this Friday for that. So any and all late work, get that done this week by Friday. The review itself that we'll be continuing to work on, you should have already turned in half of the problems by today. That's for one set of points. The other half by Thursday before the quest for the other half of the points. That's worth big points in the homework category. Quite possibly enough to just, more than count for anything you might be missing, okay? That's that category. The extra credit essay counts for the classwork category. So if you're missing a lot of classwork category things, maybe consider spending some time, put that essay together. Also, by the end of the week. For the quizzes category, of course, the quiz retakes have been available and on running, and that one actually is not by Friday, that is through until Monday. So you do have this weekend to work on those, so let that dictate your priorities this week. And then at the end of this week, we will take the quest, which is part of the final exam. I've taken basically a separate 20 questions, made like a mini semester exam on quizzes, so you'll be able to retake that as many times as necessary, just like any other quiz is, except this one counts for test points, which means it's worth more than double, really, effectively, in your actual grade breakdown there. Yeah, like a lot. Triple, no. Test is 60%, quizzes are 15. Yeah, so literally 4 times as much, okay? So I would get that to 100% if I were you. That's a no-brainer, okay? All right, that out of the way, are there any operational questions then, before we get into the math? No? All right, then you have the quarter 2 review. It's really this whole semester, but the emphasis is on quarter 2. You should have finished half of the questions this weekend, so out of 83, I would have expected 41, let's round down. 41 is okay. All right? And there they all are, and the answers should be now posted as of this morning, at least the answers to the odd-numbered problems. Unfortunately, I only had the odds available to me right away, so I'm going to have to put the evens in by hand, so expect that update sometime later, hopefully by today. That's my plan. That is like the one thing I have to do is that, and in Algebra 2, same thing. Got to write those ones by hand. Darn physical copies of books. Limitations. Anyways, so you have those. So please go ahead and look through those. All right. Check your work that you've done so far. See if that is enough to answer any lingering questions you might have. But if not, especially if it's maybe an even question, ask away. I'm just going to sit here with my fire in the background. I don't think you guys can hear that on Zoom, but got a little fireplace going, crackling fire. Should have brought tea. No questions off the bat. All right. Well, then if you don't have any questions, keep working on the review itself. And I'm going to leave the YouTube stream actually up the whole time. Anyone watching afterwards, use the fast forward button. Skip around until you see the screen actually change, and you'll know that I'm working on something. You can stop in. Listen. Oh, here we go. Ivan's got number 5 on the second page. Okay, so let me look at from the questions then. Second page, number 5. The chapter 1, number 5. Oh, the composition of functions. Yeah, that's something we didn't do, I think, explicitly this year, but you should have done it last year. This just means to take those as given and set them up. F is this, G is that. They want F divided by G. So let's see, F is square root of x minus 2 divided by G, which is x squared plus 11, and of still x. So we're not plugging in any particular number there. Just take this, see if there's anything you can do to simplify, and nothing immediately off the bat, unless you really want to try to, this is a sum of two things, so it's not like there's a difference of squares to factor that and reduce or anything. And so all you're left with is stating the domain. Okay, so from this, if you put those two things together, what x values are allowed in here, right? And remember, that starts out with, my thought of with stating their domain is start with all real numbers, okay? Assume that's like your baseline, and then eliminate things. Be like, oh, well, it can't be less than this, can't be bigger than that, or it can't be between these two numbers, or it can't be this exact value because that would make the denominator 0, right? So what values of x can we use that will give us a real number result? So first at the denominator, is there any way to make that 0? Anything I plug into the x gets squared and is automatically positive. So there's no way to get like a negative 11 to combine with positive 11 to make 0. So nope, no holes or asymptotes from that. Is there anything up here, though, that would give me an unreal answer? And that would be yes. It is still the domain of the square root function itself. I can't have any negatives inside of there. So this implies that x minus 2 must be greater than or equal to 0. We could let it be 0, that's fine. So quick algebra, add 2 to both sides. X must be greater than or equal to 2, so that's our domain. And that's an odd one, so we should have the answer already. Let's have a check. Chapter 1's number 5. There it is, and from 2 to in positive infinity, that's interval notation there. But yes, greater than or equal to 2. Oh, question just came in. Explain number 34, the radius of the circle. Can you give me a chapter section? Which 34 is that? Maybe there's only 134 on here. Zero to 24. That. Oh, 0-24. Yes. I'm sorry. The 24 is how many questions there were in that chapter. I probably should have made that clear. Chapter 0, 24 questions. That was my own little personal note when I was counting them up. I didn't take that off of there. All right, 34. Here we go. Determine the center and radius of the circle. Ooh. I didn't look closely enough at this. That's going to be a tricksy one, isn't it? Okay. There's not going to be a circle one on our test this semester, but it's good to know. All right. You're going to need to get this into, well, if you want to go algebraically, graph the line. See, that's not a line. That's rude. I'm sorry. I looked at the directions, be like, oh, the sections of graphing lines. Perfect. Parallel and perpendicular. Excellent. Little reminder of those concepts. Then like, what? Center and radius of the circle? This is not a line. It's a curve. All right. Well, let's see what we can do with this. Standard form for a circle is going to be, actually, if it's a true circle, it's just x squared plus y squared equals r squared. Right? You got the same radius on both sides. So you need to get this into that kind of thing, which means we're going to have to do some funky kind of factoring here, because we should not have any changes there. If it was to be shifted, we'd have x minus h squared plus y minus k squared equals r squared. So this is circle at the origin. This is a circle centered at h comma k, right? So you want to get this thing to look like that thing, which looks to me like you're basically completing two squares. Okay? So you're going to treat this as the x terms. Ignore the 22 for now. I want to put the x squared minus 10x plus what would let me complete the square to set this as x minus something squared. Okay? Now you gotta, complete the square. That was that quadratic stuff from Algebra 2. Yeah, okay, so we take the b term here, divide that by 2. So half of negative 10x would be negative 5x. Of course, we don't want the x, just the negative 5, right? Because that should be what goes here. Because ideally, think about when you would distribute this, you'd have two of these binomials. So x times negative 5 is negative 5x. And then you'd have the other one, negative 5 times x, so another negative 5x, right? And then you have to square it. Negative 5 squared is 25. So this would get a plus 25 there. So let me move this out of the way. That's our goal, so don't forget that. So what we want to do is add 25 to this thing so that we can reduce this, and the 25 into this guy. But I can't just add 25 to an equation. You got to add it to both sides, right? So now we have x minus 5 squared plus, we still have the y squared, plus 6y plus 22 equals 25. Now we got to do the same thing with the y. Complete the square there. So I'm just going to ignore that 22 right now. Just focus on what number I want. I need half of this guy is 3. So my net result will end up as y plus 3. It's half of that guy, but 3 squared is 9. So in order to do that, I am actually adding 9 to both sides of the equation. But these 3 together now make this. And then I just need to shove all of the constants over here, the 25, the 9, and let's move that 22. So go ahead and I'm going to do in one step subtract the 22 as well. So 25 plus 9 minus 22. 25 minus 22 is 3. Plus 9 is 12. So I get 12. Well, that's awkward because 12 is not a perfect square. That's really annoying. Why would you do this to me? Oh, well, it's going to be ugly, but that's what it is. It's okay. It's okay. Let's try not to be prejudiced against non-integers, okay? So this tells me the center is at h comma k, or in other words, 5 comma negative 3. Remember, it's the opposite of the sign that you see written there. And the radius is going to be the square root of 12. 12 is 3 times 4. So the 4 I can take out of the root. 3 stays behind, so 2 root 3 would be the reduced form of that. Let's see how I did. Remember 34? Oh, that's an even one. Okay. You're just going to have to believe me there. You also have a graphing calculator. If you can sub this for, you'd have to sub for y. That might not be that much easier. Especially without practice on parametric form. So, never mind. I guess you could test it. How could we check our work? It's always a good question. I would take the radius here, and I would add it to the x, and that would be one test point, and I would add it to the y, and that would be another test point. So what we're doing here is we're saying, hey, this exists at 5, negative 3. We've got our center down here. Our radius there is so much, so I would say add to x and test that point, add it to the y, and get that point on the circle and see if those 2 points do in fact satisfy this equation. That would be one way you could test it. You get a couple test points that should be on the circle. I feel pretty good about that. There we go. Number 7 from the logs at the end. Certainly, let's have a look here. Logs at the end. There it is. Okay, number 7. 27 times e to the power of 0.2x plus 1 equals 300. Ooh. Equation within the exponent. See, that's kind of the reason we need logs. We need to pull stuff out of the exponent, especially when it's more than just one stuff. I think that's grammatically correct. All right. So clearly we can at least divide both sides by 27. E to the 0.2x plus 1 equals 300 over 27. Those are both divisible by 3. So that's 9. That's 100 divided by 9. That's not going to be a nice integer. But don't worry about it. Fractions are just fine. So what we want to do is take the natural log of both sides, because natural log of e to the x is x, right? Think about what that means. Natural log is log base e of e to the x. Remember, your exponent rules mean I can write this in front, and so this is x times log base e of e. And ln of e is 1. But that x doesn't have to be just an x. It can be anything we want. We can even make it this whole thing. So you can put that in front as long as you take the natural log of both sides. So 0.2x plus 1 is equal to ln of 100 over 9. And that's just a number, okay? I don't know what number. 100 over 9 is some positive number, so that's fine. We can't put a negative into logs. As long as we don't do that, we're okay. So then subtract 1 and divide by 0.2 to solve for x from here. Standard algebra procedure, and just put this in your calculator. Okay, final result is going to be, we subtract the 1 and then last step, divide by 0.2. I would write that into my calculator as is. Not quite. I need to get the whole thing divided by 2. So either do that, enter, then press divide by 0.2, or start yourself off with a set of parentheses and then divide by 0.2. Okay? You don't want to accidentally only be dividing the 1 by 0.2. Order of operations is important, so add a couple extra parentheses there. Type it in, as you see here, left to right, into your calculator, and you will get a number out that should be, this is an odd one, right? What's the answer? Number 7 on the very end. I should have that one. About 7.04. Let's see how I did. A little handy dandy calculator here. Let's say parenthesis ln 100 divide 9 parenthesis minus 1 and parenthesis divide 0.2. There you go, 7.0397. Yeah, okay, so round it off. Could have sworn it said 3 decimal places. 0, 3. Because the rounding up the 9. Okay. So technically, you should still include the 0 there, 40. There you go. All right, exactly as is. I'm going to see if I can get this. Can you see that? Okay. Too much. There's the camera. There we go. That's not a bad picture. All right. There you go. Exactly as is. 5 more minutes. Last call for questions. No? All right, well, we'll close the YouTube stream here then. Same time? Yes, literally the same time. And same thing.